this is the whole connection. And now we'll go to our screen on the software, which where we will see how to configure the whole flight controller with the receiver. Now before we go forward, we have to connect the USB of the flight controller here on the USB cable. Now this is a mini USB cable which you will find it anywhere, and you have to connect it. We do not have to connect the batteries, and most important, we don't have to connect the propellers. Now for the direction purpose, I have connected the tape here just to make it easy for you to see in which direction the motors are running. Now we'll go back to the software. Now before we move on to the CC3D setup, we will need to upgrade the firmware. If it is not upgraded by the vendor, you can check it. I'll show you how. Now first we will need to open the LibrePilot GCS, double click, open. When it's open, the CC3D is connected to the laptop. Now you see the TXRX down on the part, on the down part, there is no data coming and going. Now what we will do is we'll upgrade the firmware. We go to firmware option, we press rescue. Here you see the TXRX which I was talking about. Yes. Now we press rescue, we disconnect the board, then we connect the USB again. Now the board information is here, but it says unknown because it cannot detect it. Now we say open, we upload the file. I'll put the file in the description. Old working version, open. Now you tick here, I know what I'm doing, and flash. As soon as you flash, it will upload the firmware to the CC3D. Wait it to get uploaded, and that's it. The upload is successful. Now in order to make it work, you need to click here on boot. As soon as you boot, the quadcopter CC3D will be reset, and you see, press OK. Now you see the TXRX, now it is receiving the data and transmitting the data. It's ready. You can see here the accelerometer. Yes, I am rolling it. Now I'll pitch up, down, up, down. Before it was not happening, now it is. So this is how you upload the firmware. Okay, now we'll go to the welcome screen. We'll go to vehicle setup wizard here and click on next. Please make sure all the propellers are removed. Now press upgrade, and everything is upgrading. Now it is uploading the firmware. This firmware goes in conjunction with the firmware which we uploaded. Okay, if you don't upload that firmware, here it won't. Next, yes, USB control, correct. The control is rebooting. We place next. We have a multi-rotor because we have 4 motors, quadcopter. Next, here we will select rapid ESC, which is the ESC which we have. Here this is the circuit diagram. You need to save it. I have already saved it, so I'll cancel it out, but I'll show you how to save it. You click on save, you type in a name. I'll type drone. autopilot connections. Save and close. Now next. Now this is an important step. I'll press calculate. I'll show you what is happening here. The accelerometer on the quadcopter is getting calibrated. Please make sure the CC3D is on a very leveled, as in the quadcopter should be on a very leveled surface. Okay, when you are done, you can click next. Now here we will start with ESC calibration. You must absolutely ensure that we have to remove all the propellers from all the motors. Okay, you have to read all the 1 to 7 points, and then when you have read it, then you can click on these 3 options and we can start. Now I'll be connecting the battery like here, and as you can see, the LED, the ESC has been in programming mode. We'll keep the battery here like this, and after that we'll press the stop button and the ESCs are configured. Okay, wait for the ESC calibration beep. We waited, we press the stop button, ESC confirmation beeps are there, and disconnect the batteries. Now we have disconnected the batteries. Now next, here on the output calibration, the first motor is selected. For that, please pay attention to the details, and in particular motor position and the rotation direction. To find the neutral state, we'll find the neutral state of the motor. Okay, now when I press start, it is engaged, and now as you can see, as I am increasing the value of the PWM, the motor is started rotating. As you can see, I have lowered it and then increasing it. Now the direction of the motor is clockwise. As you can see with the tape, it is very easily being seen. The safe side on the stability is 1075 microseconds, so we'll use 1075 microseconds and stop. Then we'll go for the second motor, same procedure. Okay, karo. In the second motor also we go till 1075. As you can see, it is going on anti-clockwise direction, which is correct. Stop. We go to the next, third motor, start. Again we take it to 1075. As you can see, it is moving in clockwise direction, which is correct. And next, start. This is moving in anti-clockwise direction with the same values, 1075. Stop. Now we can see, if we want, we can see all the 4 motors going together like this. So here we have completed our ESC calibration with the motor for the flight control. Now we will start with our radio control calibration. So first thing first, we have to start powering on by this. Now if you hear any warning signs, it says place all the switch in their position, up position, and lower the throttle. So first you have to lower the throttle and place all the switches in their upper positions, and as you can see, the error goes off. Now the first thing which we need to do is open the software. The welcome screen will be here. Go to configuration on the lower part of the screen, then select input here, go to remote control input, and
select transmitter setup wizard. Now click here, click OK, and we are into the wizard. Now press next. Here we use the acro model because it is for the quadcopter which we have made. Now click next. We'll use mode 2, which is throttle and rudder on the left, which is here, and elevator and the ailerons on the right. Now I'll show that the throttle means this, the rudder means this, which is the pan motion, the elevator means the pitch motion, and the ailerons means the roll motion. Next, now it says that we used to move the throttle up and down, so we use throttle here, then we use roll, which is this one, then we use pitch, which is this one, and we use yaw, which is this one, and we are done. Now we have used this switch as the flight mode switch here, like this, and now we don't use accessories, so we'll skip accessory 0, accessory 1, accessory 2 and accessory 3. Now it says that we need to center all our connections, so we'll center the throttle stick, we'll center the flight mode and press next. Now what we need to do is we need to move all the controls to the maximum extent in both the direction, which is this one. As you can see, you can do this way also and it will be done. Then click next. As you can see that now we have to check the position. When I move the throttle up, it moves up. When I move the throttle down, it moves down. When I move the yaw on the right, it moves right. When I move the throttle on the left, it moves left. When I move the roll on the right, it moves right, and when I move the roll on the left, it moves left. Now when I move the pitch on the upper side, it goes on the lower side on the screen. Now here we have to change the pitch here. When I check when I need to correct this stick, all I need to do is click on the pitch, and I can see that when I move the pitch up, it goes up. When I move the pitch down, it goes down. So it is very easy reversing of the stick. We go to next, and we have completed the wizard. Now as you can see, when I move like this, it goes like this. When I move like this, it goes like this. You can see the flight mode here. It's very easy. We keep it in the middle and then press next. Now it is the airframe using throttle off and always disarm. The timer with 30. This is default condition, and we use it the way it is, and we save it, and it's saved. That this is it for the connection, and so this concludes our Flysky transmitter calibration. Thank you. Now in the last phase here, I have connected a double side tape here, which we will peel off and place it right beside the flight controller here, and we will connect. We will pass on the RC wires through this here, so that it remains safe while on the flight. It's very easy. Now later on, what we will be doing is, instead of using zip ties to connect these to stabilize this, what we will do is we'll disconnect this and put it in from inside of one of the slots, and like this it will save some good amount of space. Here also we will do it in the same way from above, so it doesn't come in contact with the propellers while we are taking flights. Same goes with the second one and the first one here, and we are done. Okay, for this we will need a zip tie for sure. Yes, so we'll connect it here using a zip tie like this. We'll do it very lightly because these are delicate wires, like this, no much pressure, and we'll trim off the extra part here like this, and we are done. Now we'll connect the propellers. Now for the propellers we need to understand that there are two sets of propellers with us. Each set has one clockwise, one anti-clockwise propeller. Okay, so the clockwise, anti-clockwise, the direction it remains with the motor itself. So if the motor is going clockwise, we use the clockwise propeller, and the motor is going anti-clockwise, we use the anti-clockwise propeller. Now the main point that comes off is how to know if a propeller is clockwise or anti-clockwise. Now we will attach the propellers to the motors. Now this is the first arm, this is the second one, this is the third one, this is the fourth one. Now here we have the first arm as always clockwise, and the opposite arm is also clockwise. So we have two clockwise motors, we have two anti-clockwise motors. Now we have two types of propellers. One is clockwise propeller and one is anti-clockwise propeller. Now how do we know that which one is clockwise and which one is anti-clockwise? Now here we have two propellers with us, and when we look at the propellers, they have different pitch. As you can see here, they are different pitch, and there is a number on it. If you can see the number here, 1045. Yes, it's a 10-inch propeller, and on the second here you can see it's 1045R. Now this R represents clockwise direction. So what we do is we'll start putting in the propeller. Now as you can see here on the motor, we have connected the push fit shaft here. Yes, you can take a bit back. Yeah. Now what we will be doing is, we have other stuffs here. We'll attach it one by one on the motors like this, and here we have the propeller part. The upper part where the numbers are written will be shown on the upper side of the drone, and where the numbers are not there is on the lower side of the drone. So this is 1045R, and it goes to the clockwise motor, and we just hand fit it for now. Now another 1045 for anti-clockwise. Again we hand fit it. Similarly clockwise, hand fit, and anti-clockwise. Sorry, anti-clockwise. Now the second part, it's very important that important that we tighten this out in a very tight manner, because if it's not tight at very high RPM, which is about 11,000 to 12,000 RPM, it might fly off, which we don't want in midair. So please make sure that you tighten it out in the best possible manner. And here it is ready. Now here we are, and we'll be starting our testing with the drones. Now as you can see on the drone that the LED is blinking in a very continuous manner like this. And now I am arming the drone. As you can see, the LED, to arm the drone you have to make the yaw right, extreme right for 2 seconds, and it will be armed. And as you can see, the second process of disarming the drone is to make the yaw left. This is the process of arming and disarming the drone. Now as you can see, the drone when armed, it will start. Now I'll show you the controls. This is for throttle, this is for yaw, this is for pitch, and this is for roll. This is a standard known as mode 2 of remote control. Please look into that. And now we'll arm the drone again and take our first flight.